It is very important that you learn how to simplify fractions, because in all future sections, whenever you give a final answer, your fractions must be reduced. Now, the first thing I want to talk about is how we can tell whether two fractions are equivalent. Now, equivalent means the two fractions are equal to each other, but they might not necessarily be in the same form. The quickest and easiest way is to check by taking cross products. Notice 5 times 5 on one diagonal is 25, and 3 times 9 on the other diagonal of this problem is 27. If two fractions are equivalent, you will get the same cross product. For example, we all know that 2/4 is equal to 1/2. If you check those cross products, 2 times 2 is 4 on one diagonal, and 4 times 1 is 4 on the other diagonal. So that's a very quick way to determine equivalence. Now, when it comes down to simplifying fractions to lowest terms, we do not just go cancel happy. Technically, what we're supposed to be doing is we're supposed to find a factor that is common to both of these numbers. I like to just whittle away at these numbers. I start by dividing by something like 2. And I'm going to divide both the numerator and the denominator by 2. Because when I divide both by the same thing, that's essentially dividing by 2 over 2. 2 over 2 is equal to 1. And when I divide by 1, the answer I get is going to be equivalent to what I started with, just in a different form. 24 divided by 2 is equal to 12, and 42 divided by 2 is equal to 21. Now I would ask again, can I divide each, the numerator and denominator, by 2? And the answer is no, but 3 is a factor of each of these, so I'm going to divide by 3 over 3. Again, 3 over 3 is 1, and dividing by 1 does not change the value of the fraction. Now I'm going to get 12 divided by 3 is equal to 4 in the numerator, and 7 in the denominator. And now there is no factor in common between 4 and 7, so that is the reduced form. Now if I wanted to, I could check 24 over 42 and ask, equal sign with a question mark over it, is that equal to 4/7? And to do that, we would check the cross products. That may be a little bit difficult. 42 times 4 is 168, and 24 times 7 turns out to also be 168. So that's a way that you can verify that you got the right answer. Now I'd like to mention one more thing before we move on to another problem. Let's say instead of 24 over 42, I have 42 over 24. We do know that the 24 over 42 reduces to 4 over 7, and since I flipped this fraction over, you can probably guess that this is going to reduce to 7/4. And instead of dividing by 2 and 3 separately, we can divide by 6 in both the numerator and the denominator to get it there. Now, when it says write this in fraction in lowest terms, this is in lowest terms. If we were to write this as a mixed number 1 3/4, that would not be writing it in lowest terms. That would be changing the form of the number. We would rather keep this as 7/4. Let's reduce another fraction with rather large numbers in it. Now, if you know your multiplication tables, you might just say, ooh, I can divide each of these by 12 and get to my result a whole lot quicker. 96 divided by 12 is equal to 8, and 144 divided by 12 is equal to 12. And then you could say, I see that 8 and 12 are both divisible by 4, and divide each of those by 4. 8 divided by 4 is equal to 2, and 12 divided by 4 is equal to 3. Now that's a pretty quick path to get to the 2/3, which is the equivalent reduced fraction. Now, let's say you didn't see that and you started with 96 over 144, and all you did was notice that both of these were even and divided each of these by 2 to get 48 over 72. That's perfectly fine. You could divide by 2 again and get 24 over 36. At that point, maybe you'd realize that both can be divided by 12. If not, you'd still divide by smaller numbers. I'm going to divide by 12 at this point and get 2 over 3. Again, you have to know your times tables well in order to be able to simplify your fractions. So if you don't know your times tables well, I really recommend you go online, find a review program, maybe a game of some sort that tests your drill. And if you're embarrassed about learning your numbers, what you can do is you can find one of your kids, one of your nieces, nephews, a neighbor's kid, and drill them. Say, hey, let me help you. And while you're drilling them, you're actually practicing yourself, but in a secret way. Let's do one more problem. Now, some people like to go straight to a canceling method, and instead they take a number, a fraction, such as 48 over 60, and they don't want to say divide by 2, divide by 2. So what they do instead is they say, let me cross these out. I notice that both of these can be divided by 2 or 4. So let's say we divide by 4. 48 divided by 4 is 12. 60 divided by 4 is 15, and they write it that way. And then they look at the 12 and the 15 and they say, I can divide each of those by 3. So divide by 3 to get 4 and get 5. And so the answer here is 4/5. That's perfectly fine, and that's the way a lot of people do that, but you do need to know that you are dividing both the numerator and the denominator by the same thing. That's why I showed it that way first before I mentioned this cancellation process. And if you get to a point where everything cancels out or one of the numbers just reduces to a 1, you need to remember to have that 1 there. For example, let's say we have just a simple fraction like 3/9, and we go to divide each of these by 3, and you say, okay, divide by 3, okay, and you forget to put the 1 there, and you only have the 3 in the denominator. If you forget that 1 and only have 3 listed as the answer, it's wrong. It needs to be 1/3. So be careful with that.